Yo, 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 let's get this started. So, we're still working on terrain. Yesterday's stream was more a stream of understanding than actual progression, I would say. And although I still don't want to say that this calculate normal approach, like that I fully understand it, I somewhat understand it, and to 90%. And this delta here makes very much sense. So the further away neighbor points are, the more up the normal will be. The closer it is, the more they will affect it. So what I think we're gonna do today is we're gonna clean this up. We're just gonna go with this. Although yeah, we're just gonna go with this approach. So we only base the normal on the connected vertices and skip this and this. So that's the first thing we're gonna do. But thoughts, implementation notes. Implementation notes. Normal calculation. I would love to have. Does it support one more header level? Let's try it. So. Connected vertex neighbors. Normal calculation, connected vertex neighbors. Beautiful. We had 4 connected . Calculating the normal NP for point but using its connected neighbors left, up, right, down. Is done with the following calculation, and so this one is, let's see here, left, or actually left minus right. Yeah, I think so. L minus right times up minus down. I think it's as simple as this. I think I would like pros and cons here as well, but with this approach, I think at least we didn't use distance to neighbors. Let's see, note current implementation doesn't use distance to neighbors. Which means that it can be done directly from the, or directly with the height map. What's up, Cooler SK? Yes, indeed. And I watched that movie yesterday and it's insane. That's all I have to say about that video. It's insane. Makes me want to do a voxel engine, you know? A voxel based engine. Mega brain indeed. Okay, so implementation notes here, normal calculation. I'm just writing all of these things down because I want to be able to make a nice video of this, like my approach to terrain creation later on. Let's see here. So I just want to write about terrain patch, this one as well. Yeah, I saw the message, but it was 4 AM, so I didn't write a response. Okay. What were you doing reading Twitch chat messages at 4 AM? Just chilling in the middle of the night. Ah, okay, yeah, can relate. Okay, let's just write this one quick as well, and then we can move on. So 4 connected neighbors, 8 connected neighbors. Calculating the normal 4 point left, up, right, down, up, right, up, left. Down right and down left is done with the following calculation. That's a long sentence, but let's do it. And it's pretty much just this, but we also do plus, what is it? Left to right, so it's up left minus down right times, I think it is up right minus down left. Then you add them all together and do the absolute. Okay, so that's pretty nice. So now I know when we do the video later on, we can use this. Okay, so the normal calculation or the normal function we're going to rely on is this one. Indeed. So we're just going to skip this one. We're just going to skip this one. Recalculate tangents. We're gonna yeah, we're gonna recalculate normals first, then we're gonna do recalculate tangents. And yeah, so we do. Although I wonder, maybe we just want to call it calculate normals. Can we make this a bit prettier? Yeah, I think we're gonna do it like this. We're not gonna send in vertices, and we're not gonna return. Did you vote on the poll on the channel? If so, what's winning? I checked the poll, but I couldn't decide, so I haven't cast my vote yet. What did you vote for, by the way, Cooler SK? Yeah, let's do it like this for now. Rendering, I want to know more. Yeah, rendering would be a very nice. A very nice subject, I think. I just want to clean this up. We're gonna commit it and hopefully move on. Or I think we want to do, yeah, we want to do it like this. Private vector 3 normals. Rendering and multi-threading were pretty close when I voted about a week ago. Well, more like last week. Let's take a look. Let's take a look. Here we go. Yeah, I think like rendering is multi-threading also very interesting, but but I have now cast my vote at least. Yeah. Rendering and multi-threading were still the one closest to each other, but multi-threading was winning with like 30 to, what was it, 27% or something like that. This, yeah, I think we're gonna do this. Let's see here, normals, and we don't return anything here. We do void, we do private, we don't redefine anything, so normals is equal to this. We do this, we don't return. I want to fix this one later on. What's up, Ludwig QC? How are you doing today? And instead of doing this, we just do normals. So we calculate. Fuck, I should be able to do normals. is equal to new vector 3, yeah, vertices dot length. And so then we calculate the vertices, then we calculate the triangles, and then we do calculate normals, but let's rename it recalculate normals. Texture layering. Interesting. What you're doing texture layering? Like, what are you going to use it for? Fuck, I wonder, do I want... No. Let's do it like this. Yes. Yeah, we don't want this anymore. Merpy Derpy, what's up, Cypher? What's up? This looks good. I don't care about these flags. Let's keep them here, but whatever. Let's see if it works. AA, all good. Nice to hear. Same here. Still have a little bit of a sickness going on in my body, but other than that, it's okay. Okay, so let's see. Ludwig, my buffer actually used multiple layers, but no SDN elevation versus no textures. Sounds interesting. I just assign colors to vectors. Do you use those colors then to differ between textures, or am I way far off? I'm trying to wrap my head around it, but I don't fully understand it. But hey, if it works, it works. Okay, let me just commit terrain patch. I think we got normal working here. And then I want to commit game environment as well. I'm just gonna do it on this screen, I think. Actually, let's do it like this. No grass. We're waiting with the grass right now. We're trying to get the terrain ready for it. It's not quite there. Let's see here. But maybe not soon, but you know. Let's see. Terrain patch works wonderfully. Terrain patch. Let's see here now. Implement custom terrain solution. Yeah. Yeah, like, we know why this is happening, and this is what we're gonna fix. As soon as I've committed terrain patch and terrain base, we're gonna fix this seam here. It's gonna be amazing. It is going to be amazing. So now I just want to commit the terrain base as well. Let's see here. Dimension, resolution, subdivision, height, range. Material, terrain, data. Yeah, let's keep that one here for now. Test flag, we don't use these right now, but it's okay. We do on validate. This one right here, it doesn't sit that well with me. Like I like when things are explicit, and this just like, yeah, you fade this out because the outer parentheses is not needed because this one has precedence over this one, but this is still a tiny bit unclear to me. Like, this is so much better, but if we do it like this, it gets blacked out, or whatever you call it. Let's see. Okay, beautiful. So let's start with this. Issue 83. Beautiful. Okay, so the reason we have these this seam here in the middle is because when we calculate the normals on the edge here, we don't use the neighbors in the different patch, and that's what we're gonna fix now. So I wonder if in terrain base, I think we want to set up, like, we want to create a terrain patch object first, and then we want to set its neighbors, and then we want to generate them. I think. Like, there's really two approaches to do this. First, we can do we can loop through and create them, and then we loop through them again and calculate normals and such. Or I think that's the one I like the best. Or we can do it like this, and when we generate the normals, we just generate the normals in the middle, not on the edges. And then when we connect them to neighbors, that's when we calculate the normals. Maybe that's better. I don't know. Let's see if we can do pros and cons. The distribution for the terrain is just Perlin noise. What's up, Robert Pattinson? Hello, I left a question in your Discord. Why I didn't answer? Oh, fuck me. I'm sorry, man. Let's see. Do I dare open the Discord here? Maybe I do. Is it the one about the Unity shaders that can be applied on a terrain object? Is it that one? Locomotive. No. We can definitely answer that. Yeah, I'm gonna look through it after today's stream. Although I'm not sure. If I can help. But I will look through it later on. Falinier, thank you so much for the follow, appreciate it. Ludek, like the noise here, we're just doing this to test things. We're not gonna have it like this later on. When we calculate the normals for this terrain, we need to take the neighbor patches into account. That's why we get this problem here. So, two approaches. Is it visible if I have this scale? Yeah, it should be visible. Let's see here. Edit. So here we have normal calculation. And then I want to add a 1, 2, 3. Is that the correct? Implementation nodes, normal calculation. No. Patch. Or actually, let's call it terrain patch communication. Tricky part is you have 4 sides. Yeah, I think we can handle this. And that's a nice use of the redeemed points. Everyone appreciates a good programming joke, right? Terrain patch communication, yes. So, the terrain patch needs to communicate initially to do proper normal calculations, but eventually also for things like sharing navigation data to entities. This is also one thing. How the hell am I supposed to write this? So, singular entity, if we have many, it's entities. But when I want to like code it as the actual class, I guess we're gonna have it to do it like this. Oh well. Good morning, Geralt. Hope you're ready for some terrain work today. Oh, much better. Much better. Like it with the emojis. Makes it easier to understand, you know. The terrain patch needs to communicate initially to do proper normal calculations, but eventually also for things like sharing navigation data to entities. In fact, this is ugly. Let's just do this. Okay. Ready, of course. Nice. So, here I want to write some pseudocode. Can we do it like this? We want two approaches here. Approach 1. Oh yeah, that's issue reference. So it's basically for each, or actually for, it's been so long since I wrote pseudocode. Robert Pattinson, is this LaTeX? Actually, we noticed yesterday that you can write mathematic notations with the same logic you would in LaTeX. So that's amazing. You can do that in Markdown on GitHub. It's wonderful. Let's do just for each terrain patch. For each terrain patch. We don't need this. 1, 2. Terrain patch dot generate middle data. Generate center data, basically. If terrain patch has neighbors, terrain patch, or if terrain patch neighbors are instantiated, terrain patch dot set neighbors, and then we do terrain patch generate edge data. Something like this. So we create a terrain patch, we generate the center data of the terrain patch, not the edges, not the leftmost edge, rightmost edge, top edge and bottom edge. And then we check if we have generated the neighbors to this patch, then we set those neighbors and we generate edge data towards that neighbor. Like, this is one approach. I'm not entirely sure this is the best one. So terrain makes sense, but still. Good morning, Harukanan. It's very nostalgic to read all these programming jokes. Like, if you've been a programmer for a while, you've heard them all before, you know. Ludic, I just set the data in a list and retrieved the last stacks to match the first one. We'll see. So this is approach 1. Approach 2. For each terrain patch, 1, 2. Actually, we want to do this as well. Terrain patch dot instantiate. So here we do terrain patch instantiate terrain if terrain patch neighbors are instantiated, terrain patch dot set neighbors. And then we do for each terrain patch generate data. And I think we're gonna go with this approach. I just like it more. I think it is a bit cleaner. It's all down to, like, generate edge data. Will we need a method like this during instantiation? Like, is there ever going to be yeah, I think we're gonna start with this, but I'm gonna keep this one in mind. We might need that one. Was up almost the entire night with the kid. Damn, another one of those bad nights. Yeah, I think the average age on Twitch software development section is a bit higher than on the other sections of Twitch. It's just a hunch, you know. Count yourself lucky, Cypher. Count yourself lucky. Let's implement this one and let's see what we can do. So it would be position. Here we create a terrain patch object. We're gonna clean this up as well. We're gonna do this. Terrain patch. When we do static methods in terrain patch, do you want them at the top or at the bottom? Like, what's the best? Do you want, like, if I want to do a method that is public static terrain patch instantiate or create new, do you want it in the top here? Damn, chickenpox, is that... Yeah, vattkoppor. Okay, I get it. Is that still a thing here in Sweden? I remember when I was a kid, if one of your friends got vattkoppor, you wanted like your kid to get it as well, so you sent them over to get it from the first kid. Is that still a thing? Pox parties indeed. It was pretty much like that, because you wanted to get chicken pox in your childhood instead of when you're old, because it's way more harmful when you're older. Yeah, that's weird. Maybe like my kid is, what is he, 5 years old. Maybe I'm gonna have to start searching for pox parties soon. Do we want it like this? I think we do. Terrain patch. Although I wonder if I can do we had a pox warning at nursery, but she didn't get it. Can you get vaccinated for chicken pox these days? Is that something people do? Position plus offset. Yeah, but it's not done over here, mostly USA, I think. Okay. But I mean, so like if your kid doesn't manage to get it when he or she is a child, would it be good to vaccinate against it? We don't do that here unless there's a very good reason for it. Okay. So it's like, if your child doesn't get it during childhood, you just pray that he or she doesn't catch it in adulthood. Okay. Yeah, it is very dangerous to get it as an adult. Yeah, that's what I'm thinking. So if you don't manage to get it as a child, maybe you should get vaccinated against it. I don't know. Fucking sicknesses, man. Okay, let's do it like this. We want to send in a lot of things here. Terrain data, I think we can wait with terrain data. I think we can wait with material as well. Instantiate, yeah, we're gonna skin this out a bit. Terrain data. I'm gonna wait with this one. I'm gonna wait with material as well. I'm gonna wait with height range as well. We don't do generate here. We don't set material here. Create new. Create new. We want to send in position. So vector 3 position. Oops. What is it? Vector. Position, dimension, resolution. So vector 2 dimension, vector 2 int resolution. IJ, let's just call it and I wonder if I want to do if we can do terrain patch. Terrain patch is equal to new game object. Can we do dot add component terrain patch? Dot instantiate. Is this ugly? Here we just do position, dimension, and resolution. Would be nice if we could do it like this. Let's see here. So this returns a game object, right? Or do we need to do parentheses? Yeah, cannot implicitly convert from Unity Engine game object to terrain patch. So this results in a game object, so then we should be able to do add component terrain patch like this. Okay, that works, good. And this returns a terrain patch, so we should be able to call instantiate as well, right? But that's where everything gets fucked up, right? Or is this one? Oh yeah, because instantiate does. Yeah, okay, I get it. Do I want to do this? Return this just to be able to do this? Nah. No. So what we're gonna do is we're just gonna do it like this. But is this? Yeah, and then we do terrain patch dot. To be honest, I don't think this is that much nicer than just doing it like this, so terrain patch object, new game object. Do I want this one on top here? Yeah. And then we're gonna set up neighbors and stuff, and then we call generate. So terrain base, what we do here is create new. What was it? Position dot plus offset dimension dimension subdivided resolution subdivided. I wonder how I want to handle the terrain patch neighbors. It would be very nice if we could handle it within a, let's see here, neighbors is equal to how do you do matrix C#, an array? It's like, so terrain patch three, something like this. If we could store it like this, I wonder if this could improve the, like if this would make the code a little bit clearer, and if we could do some mathematic magic later on when we get index. So the idea is that this, so if we keep it like this and we say that this has an index of 1, 1, like that means that we can do, if we want to go to its left neighbor, we just do like 1 minus 1. If we want to go to the right neighbor, we do 1 plus 1. Instead of having like define them like terrain patch left neighbor, terrain patch left up neighbor, and on and on and on it goes. Ooh, I think we can do very nice things here. So then we can pretty much do get index, so we can have a method that is I wonder if we can make this very, so let's do, we do get vector at index ij. Can we do something like this then? So we do int I patch is equal to I divided by resolution x, int j patch is equal to j divided by resolution dot y, and then we do int I recalculated or whatever exactly. And then we do neighbors I patch j patch dot get vector I c j c. Is this a weird way to do it? Although I wonder, if j is -1 here, we get -1. I think we get -1 here, right? No. Probably overthinking it, but it would be nice to be able to arrive at something like this. But if so, we would would be so nice if it was solvable this way. I think like the logic here is a little bit wrong right now, but I wonder if it would have to be What's up, Aya Plays Dev? Let's just do it easy. Fuck. It's gonna be so ugly. So if we do, let's see here, private, if we change get vector to B, so it's gonna be like this. If x, come on, if x is bigger than or equal to resolution.x, yeah, okay, best case scenario we can do something like this. Like, I think this way of storing it is still pretty good, I think. Get vector, I'm not entirely sure we're gonna call this one too much. If I'm gonna be honest, it's probably just going to be during instantiation. It's gonna be a little bit when we recalculate normals, that's true. That is true. Okay, but let's just do return vertices. Can't you do it like this? What do we need to do? This is not how you do it. Where is it? And now it's just a regular method. Let's do this. Let's keep it like this. But I'm pretty sure this is how I want to store the neighbors, I think. Let's start with doing it that way and see if it turns out good or bad. Is it like this you do it? It's been so long since I worked with matrices. this one will instantiate it with nil here, right? Actually, I think we want to wait with this one until instantiation, because finally we're going to do this. Neighbors is equal to new terrain patch, and neighbors 1 1 is equal to this. But if we instantiate it here, we might get problems. So I want to do neighbors 1 plus x offset 1 plus y offset is equal to neighbor. I think. Like, I want to be able to avoid this shit in a somewhat nice way. But It's probably gonna end up something like this anyway, so public terrain patch, get terrain patch, int y, if x is so fuck, how do I want to do this? Yeah, I don't like this one bit, but if we do int I, int j, if I is bigger than resolution.x, I plus 1, else if, come on, I is less than 0, minus 1. And then we do the same with j. I just don't. It must be a better way. You could probably do it like. Couldn't you? Okay, let's say that we do it like this. J, Y, J. Shouldn't you be able to do it like? Shouldn't you be able to do int I is equal to 1 plus mathf.ceil? Oh, I'm not too sure. Let's double check this one. But mathf.ceil x divided by resolution x. So let's say that resolution x is 100 and this is 101. Actually, yeah, we want it to be bigger. If this one is 100 and this one is 100, we get 1 here. So you could probably do. So if this one is 100, this is 101, we do ceil, yeah, then we will get 1. Not what we want. But actually, if we don't do anything here, we get 100 divided by 101, so that should be 0, right? But if this is 101, we get 1. If this is 102, we get 1, right? And what if this is, if it's 0, then we get 0. If it's -1, then we're fucked, right? Or do we get -1? No, we don't. That, Robert Pattinson, is probably... yeah, it's not top 5 programming jokes. I'm okay with top 6. Nice, because it is on 6th place. It should exist a nice way to write this, right? I took part in a chess tournament. I ended up on 3rd place. There were 4 competitors. I don't know if that's a joke or a life story at this point. Congratulations then, I guess. Because I mean, like, I still think that's good, you know? I would never dare to enter a chess tournament. Jesus Christ, that would be... Oh well, so if we do it this ugly way, then we can just do return neighbors, but then we need to check if it's null. And like, what's the default approach we want to take to trying to fetch values without or outside a patch? Should be wrap or decisions. One guy I played with even shook hands with Karpov. Respect. So by proxy, you shook hands with Karpov. Is this how I want to do it? So something like this. Would love to be able to simplify this and this, but I don't know how. Do we want to do X modulus resolution? Let's see. Oh well, let's go with this one for now. And I wonder if we also want to do get terrain patch. Oh, I'm not too sure about this, because then you want to do... Okay, like, let's put it this way. Like, implementing this is pretty straightforward, but like, that approach also includes a lot of if-else checks, if-null checks, and so on and so on. I'm just sitting here thinking if we could clean it up a bit, but I'm not. Like here, get terrain patch, here we could do, so I and j, like this way I and j will never be less than 0 or bigger than 3. So we will never be out of bounds of this one, but we might fetch something that is null. So maybe we want to do return, if this one is equal to null, then we return neighbors 1 1, otherwise we return this one. So that's one null check. Or can we check it like this? And I'm okay with this if we could clean up this. Okay, so then you also want to do public. You want something like this, but you want a function that wraps. So, I don't know, vector 2. Is this how we want to do it? Maybe we can do index private int get wrapped index, or just index wrapped int x int y. Would be so nice if we can do it here. What is it? So could we just do it as x resolution so actually index x resolution, and then we do y resolution dot y plus 1. So this would work for if this one is bigger than this, right? So if resolution x is 100 and this one is 101, we get 0. This one, but if this one is -1, yeah, then we don't loop through the other way around. Let's just implement it the bad way for now. So get terrain patch public int get index wrapped. So we do something like int x, int y. So if we're big on resolution X, we do X is resolution X, right? I think so. And if we're less than 0, we do plus equals to resolution X, right? And then we do the same with Y. And then we just return index X, Y. So with these two methods, which I hopefully can simplify and clean up, we can hopefully make it look a little bit nicer when we fetch values. So the default value here is actually get terrain patch. If we're at the end, we just wrap around on that one. I don't know if I like that, but maybe. So let's say that we are whoa, this is not entirely wrong. We want to do X and X and Y and Y. So this basically means that if we try to fetch a value at the edge of a terrain patch that is on the edge, i.e. there's no more terrain patches there, then we're going to get the same terrain patch we're currently in. And when we do this, we're going to get index wrapped, so we're going to get the start on that one. Let's keep it like this for now. So hopefully now we can clean this up a bit. So it's more like going to be this should only be called vector as well. And we do private float height int x in yeah. Fuck. You probably want to do yeah. And here we do terrain data dot height. That's true. when we work with height data, we're working with textures, so we don't work with indices like this. And that's unfortunate. So, what do we want to do instead? Okay, so in this use case, I would like something like, let's do vector to int index, and then we do index index.x index.y. To int index get height index.x index.y. Fuck, I just hate it when you don't have any form of consistency. So yeah, we're probably gonna change this to, so every time we want to work with indices, we're gonna do either vector to int or just one. So this one should be vector to int, this one should be vector to int. Ah, fuck it. So return yeah, of course. So we should be able to do float up is equal to get terrain patch, and here we work with XY as well. Fucking hell. But would also like to avoid creating new structs all the time. I think maybe it's not that bad. Yeah, that's what we're trying to do right now. So let's do vector to int index is equal to new vector to int now get terrain patch ij. So then we get a terrain patch back, then we want to do height, and we want to do get index wrapped ij. So that's what we do. Up, get terrain patch, dot height, get index wrapped. That's pretty much what we want to do for all of these. But up is going to be I plus 1, I plus 1. But then we do these. Let's just see if we get the correct result here before we continue. And up is actually going to be J. Yeah, there's a lot of wrongs happening here right now. Plus J. And then we have down, which is going to be negative. And then we have right. And then we have left. And then up, right, and down, left. Up, right, right, yes. Plus 1. Plus 1. And down, left. And now, thanks to our extremely ugly methods up here and the inconsistency, we should be able to get rid of those seams between the patches if we properly set the neighbors as well. And that's what we're gonna do next. I just wonder, like, okay, get terrain patch. And then from that terrain patch we get height, like a lot of ways to clean this up. But let's see, so terrain base, we do terrain patch, create new, and then I wonder if yeah, we don't save them here. Yeah, we might want to do that as well. So private now it's a question of, do I want to save all terrain patches here as well, or can we skip that? How do we want to save it? Terrain patch. Terrain patches. Generate. And we might as well do terrain patches ij is equal to create new, and then we want to check basically if, yeah, let's do it the naive way again. So if I is bigger than 0, if j is bigger than 0, this is the point where we want to set up the neighboring references. And like when we do this, do we just want to set up left and top left, and will that fix all the other ones as well? So if we loop through this list, if we're at this one, we check if I is bigger than 0. It's not, because this is I and this is j then, I suppose. So we don't have a neighbor to the left, so we check is j bigger than 0? Yes it is, so then we take this one. But do we only need to check these? Will everything else? So when we move here later on, we get this one. We get the diagonal. I think that should be enough. Yeah. So the extremely naive way would be to do I bigger than 0 and j bigger than 0 here. So if it's bigger than I, we do terrain patches I j dot set neighbor I, what is it, -1 j. Oh yeah, we want to set the terrain patch as well, so that will be and then the question is, actually this is not correct. Here we want to do -1 0. And then we want to do this, I think. So we just couple them together. So this one's left neighbor will be this one, and this one's right neighbor will be this one. And I want to do the same here and the same here, like gonna get so many errors, I think, but fuck it. Like this. So a lot of things can go wrong now. So this, setting up the neighbors, could go wrong. And this as well, get terrain patch and then index wrapped. But we'll see how it works. But before we do that, I just need to run real quick and grab a cup of coffee. So I'll be right back. Okay, back. Sorry about that. So, how should I put this? Like, we're doing progress, but... Or I guess, like, we're gonna find out if we're doing progress right now, if we try and run this. But even if it turns out we are making progress, it's not very nice progress. Like... It's a little bit dirty, you know. But let's see what errors we have. What we need to fix before we can even run this. Ooh, one more thing. So I think we're gonna get... Okay. Yes. Makes sense. So, no errors at least, I don't think. Got a lot of warnings. Oh yeah. But we don't actually get any terrain because right now we just do... We create a lot of terrain, we set up the neighbor links. What's up, I'm me, how are you doing today? And that sure was a fast coffee. It was locked and loaded pretty much. So then we pretty much want to do, I wonder, can we do for each terrain patch in, or terrain patch in, can we do terrain patches? Can we loop through over a matrix like this? Yes, we can. doing good, coding away here and wondering what the hell you're doing. And so am I. We're right at the start of a custom terrain generation system, and let's leave it at that. So terrain patch dot generate, I think. Trying to normalize normals between patches, right? Yeah, pretty much. We're trying to calculate normals right at the edge between patches, which means that each patch need information from the neighboring patch and so on. And it's the neighboring system that isn't perfectly set up. Okay. And it's on. Terrain base 35, terrain base 81, terrain patch 122. Generate 81. Right, quote the problem, unquote. What are you implying with those quotations? Okay, so in generate 122. Oh yes. Yes, that's true as well. Yeah, we have some data we haven't checked. It's always the problem to make the normals between patches calculate fast without massive cache hits. That actually makes me glad to hear, because yeah, we're gonna get massive cache hits here, but we're gonna get more than that. But let's see here. Yeah, exactly. That's the approach we're taking now. This approach entails massive cache hits. Yes. Okay, so we haven't set the terrain data yet, and I wonder if there's one more thing we haven't set. Terrain data container. Previously we had it Previously we set it on our instantiate method. We don't anymore. So I wonder if I want to do, let's see here. Yeah, I think I want to do it like this. Generate if resolution is less than 0 or resolution y is less or equal to 0. Or terrain data is that so? Okay, let's check it like this then. And also I forgot to do so I think we want to do this like terrain base. Right now we have just set up a terrain data here like this. Oh yeah, it's the material as well. So let's do terrain patch, set neighbor, get set public void set material. So here's what I'm wondering here is, do I want a method that is set terrain data container and we send in a data container, or do I want a set terrain data and we send in a texture 2D? Probably the second one. We're gonna change it a lot down the road, I think. 2D terrain data. Wait, do we have... Oh yeah, we have it in a terrain data container right now. Good. So what we want to do is call this one, I think, with height range, new data. Okay, so let's do it like this. Set terrain data, range, height, range. And terrain data container. Don't we have one of those? We call it terrain data as well. That's... Resolution.x, resolution.y, height range, and terrain data texture. So in base we want to do create new so we pretty much want to do everything except generate, so it's gonna look like, maybe not the prettiest, but terrain patches ij set material, we call it terrain data here. Still the same problem. $122. I'm not entirely sure about that one. Let's see, delete 0. Okay, no errors, but no visual results. Because probably because one of, I would guess that one of the checks here fails, terrain data is not equal to null. We create it here. Do we call it? I think we... No, we do. Shouldn't be a run problem, I don't think. Like, are we doing something? Yeah, it's not. Okay, so something doesn't get generated correctly, and I wonder why not. Do we get to this point? Okay, we don't. Okay, that's nice. I think. So one of these checks fails if less than 0, or this one is less than 0, or terrain data is null. What the fuck? That's how it should be. Okay, and now we get an error instead, so let's take a look at that one. Terrain patch 177. So get terrain patch j-1 height get index wrapped. So this one, I guess. Recalculate, yeah. So I'm pretty sure this one returns null. So get terrain patch. I thought we fixed it so that it couldn't return null. First of all, 1 is always equal to this. So then we calculate +1 - 1, +1 - 1. So if why did I put that one there? So if this one exists, returns it, otherwise return this one. Default back to that one. Okay, now we have terrain and I mean, it looks a little bit weird here. But yeah, I don't think that's entirely correct, or is it? Okay, we can probably double check this real quick by doing, let's see here. But it's also extremely doubt. But let's see if we can double check it by doing okay, let's do it like this. Or test flag 1, generate test flag 1, and then we do create, let's duplicate this one. But here we do test flag 1, so let Unity calculate the normals. How does that one look? Yeah, of course. And in Garden 1 we do subdivision 1. So we get this instead, and then we want to do texture 64 times 64. I thought we would be able to... Actually, let's delete that one and fix it real quick in GIMP here. Okay, so the wrong normals might actually make sense since we don't really have a... It's not repeatable. So it might actually make sense. But let's try it. And garden 1 here we do, instead of this data texture, we use this one. Yeah, they're exactly the same except for in the end here, I think. Actually, they are. Ah, okay. Nice. Although it worries me a tiny bit, like, okay, we don't have a... This texture is non-repeating, so that's why we still get a little bit of a... It's not really a artifact though, or is it? Maybe it is. I'm not sure about this. Even though this one yields the same result. Is it a... Is it a problem with the method we're using? Still looks extremely weird. this is test flag 1. Test flag 1 true. Terrain patch. So this is how Unity would... So this is just one patch, and this is how Unity would calculate the normals here. But instead, if we do... times 64. Let's generate some noise that is repeatable. Tileable. Fuck it. Okay, so this is Unity's... let's see here. This is how Unity would calculate the normals for this one. So the texture is tiled, but the terrain is not. And our solution would look something like this. So exactly the same, which means that I would say that we have the normal calculations between tiles properly set up. Not the cleanest implementation, not when it comes to how it actually looks in code, nor like the most optimized, but it works. I think that's pretty cool. But I do wonder if we go back to this one. Like, it's not tileable here, but we still get vertices that looks like they're tileable. Do wonder why that is. We read height here, terrain data height ij. And then we get pixel. Is this one? Do we do anything here that's linear color space, MIP count? No MIP. Texture format. Like, I wonder if data dot wrap mode. Yeah, let's do texture clamp. Yeah, exactly. Okay, nice. I think we're gonna go with wrap or repeat? Or do we want to go with mirror? Repeat, I think. That's still nice. Let's go with a repeatable texture then, because it looks a little bit nicer. This one. I think we can delete. Let's save them. Still wondering though about this setup and this approach right here. Okay, but also let's add terrain base, or actually terrain patch. Set neighbor, set material, set terrain data, public void, set layer. Is it? Nah, I don't think it's layer mask we want to do, but game object dot layer, so it's just int layer. Pretty rough performance, I have no idea why. Okay, nice. Let me just try Is this so? There we go. Extremely rough. But at least the normals are fine, I guess. Okay, one thing, 56 times 56, if we just do, let's subdivide it just once, what kind of performance do we get then? Should probably get a better performance. We don't. Worse. FPS. Cypher, do you still need that grass texture mottled look now that you have terrain? I'm not sure I understand what you mean. Mottled look. A little bit. Let's do garden. Let's subdivide it 4 times. Can we do it like this? Okay, we get an error here, I think. Or actually, do we? It's not entirely correct here. Okay, let's do garden. Okay. Ooh, this is weird. Let's see here. 1 times 1, that works. 2 times 2, that works. 3 times 3 does not. Then we can get overlapped. Okay, that's weird. How did I screw up my implementation in such a big way that... Okay, so 4 times 4 doesn't work either. It becomes smaller. And... yeah. The fuck? Let's see. I mean, like... how you have the grass, it's got that different heights to it. Remember before I said it looked like cow print and needed more blur? Oh, yeah. Oh, yeah. Like that texture is still something I think we want. So you're talking about, I think you're talking about, it's not visible here, but it's a... grass proportions texture. So it pretty much says that in this area the grass should be taller or wider or more bent, and we're still gonna need that one, because that one is going to be replaced by a player-made texture later on. Resolution subdivided. Subdivision XY. Okay, what is happening here? I think it's something with position. I times dimension subdivided delta. I just want a big flowy meadow look. I think we can... So like you want the grass to be the same size everywhere, or... Let's look into that soon. I want to fix this subdivision problem first. How the hell did I manage to fuck up subdivision so much that subdivision 1 works, subdivision 2 screws it up? Dimension subdivided dimension. This should be correct. Or actually, so if we have 3 here, we get I think the problem lies with this position here. It should be enough with this one, I think. Pretty sure it should be. Stay in your path, I'm just being annoying. You're not being annoying. What? This is being annoying. What the hell is going on here? What do we have? We have garden, subdivision 4. 1, 2, 3, 4. Yeah, I'm pretty sure it's the position that gets fucked up. This is... Okay. Dimension subdivided. That's just dimension divided by subdivision. Dimension subdivided delta, however. Yeah, an offset is supposed to be used to offset it from the center. Yes, okay, now I'm starting to understand what I was doing here again. But this one doesn't seem to be correct, since it works for 2, but what happens if we have 3? If we have a subdivision of 3, we get 3, so 2 to the power of 3, that's 8. 1 divided by 8 seems to be the correct. This one should be here, but yes, of course, this one needs to be based on yes, this one should be, we need to calculate the offset within here, I think. But then again, so we should be able to just do precision here. 0 J. Yeah, what the fuck? It should be, shouldn't it be this plus that? So this is the offset, so instead of starting in the center, we just start in one end, and then maybe. Okay, not really. But while we do this as well, let's use this material. So what do we have now? Yeah, the offset doesn't seem to be entirely correct, but we are... okay. Something like this is how we want to end up. And what is this? This is a subdivision value of 4. Is that actually... okay, yeah, okay, something is wrong here. Yeah, the subdivision is not entirely correct. Dimension subdivided, subdivision, yeah. So here we calculate subdivision 2 to the power of the subdivision number we have. We don't do it here, so vector 2 subdivision, is that one an int, by the way? So we want to do vector 2 int subdivision yeah, I think we're gonna call it that. And then we do to the power of subdivision constant dot x minus 1. Yeah, let's keep this one as float then. Dimension subdivided, so we should use subdivision here. Beautiful. Dimension subdivided delta. I don't really think there's a difference between those two. Let's skip offset as well. Resolution subdivided, subdivision x, y, we do int here. Do we need to do this? I think we want this one to be an integer. Pretty sure this is how we want to do it. Or I'm 50-50 sure. Attempted to divide by 0, that's not good. So subdivision x, we tried to divide with 0 here, but shouldn't be able to. 2 to the power of 0 should be 1, right? So we should never. What the fuck? Okay, so if this one is 0, that's true. I wonder if... Yeah, maybe we want to start with 0. Okay. We're not really there, but... And since each terrain patch has the same texture, we get a smaller and smaller pattern, but that should be okay. And if we have a subdivision of 4, it's actually 2 to the power of 4, right? So what is that? Or is it? 3, 4, 5, 6, 7, 8. No, it's not. It's 2 to the power of 3. That's a little bit weird. Is this how we want to subdivide it, or do we just want to do... So if it's 1, we just do it as 1. If it's 2... Yeah, so maybe instead of calling it subdivision, maybe it should be like the number of patches we go. So if it's 3, it shouldn't be subdivided 3 times. It should be 3 patches. Is that more straightforward? Oh yeah, but yeah, okay. The reason we went with subdivision like this instead is because otherwise we might get a resolution that is off. Like we might get... So how would you divide resolution of 80, that's an integer, with 3? And that's not very good. But also 2, so this is subdivided. I probably want to do, yeah, let's clean this up now. Subdivision, constant. I think we want to remove the -1 here. It makes a bit more sense then, I think. So subdivided 0 times, we just have the default size. I think it's 80 times 80. Dimension 160 times 160. Yeah, that's true. And if we subdivide it once, we get this. So we get 2 times 2. If we subdivide it 2, then it should be 4 times 4. 1, 2, 3, 4. If we subdivide it once more, it should be 8 times 8. Beautiful. So now we just need to fix the patches themselves. They spawn perfectly, like they are neighbor to neighbor. But the full terrain, the center of it, is a little bit off, to say the least. So we calculate position here by doing minus dimension x. So let's go with, we have a subdivision of 0, 0, so this one is dimension. Oh, then we offset by half. Do we want to do... Because in terrain patch, when we generate the patches later on, we also offset by -1. So maybe that's what we want to do. That looks to be in the center, but looks to be perfect. There we go. Great. So my question now, what I wanted to try is, actually let's do this. So now we have a subdivision of 1. Let's play it. Let's put on yeah, let's put on the grass again. Oh, do we have... Did we have duplicated terrains? That sucks. Okay, 100. Have some stuttering problem today as well. Probably because of my computer. Okay, so around 90. Let's try to up this. So now it's 4 times 4. I think we can improve this quite a lot. very interested in those stutterings we're getting, those spikes. Is that one of those? Editor loop 8. Okay, but subdivision okay. Grass okay. And we get extremely low FPS here because we're rendering 4 terrain too many. 100 FPS or 90 FPS. I guess I'm okay with that. Just list requirement as 4090 ease fix. Yep. Probably gonna do something like that. It almost looks like there's a lot of grass over here, but it doesn't really. Like, compare. What is it? Oh, this looks so much nicer. Jesus. Are you serious? Yeah, I need to get on this. Dude. I think we can simulate this. Yeah, I think so. It feels like one of the last changes. We made is not really. Actually, it is, but maybe it's not too much. Too bright, definitely. But then again, it's way too bright in that direction. Damn, it would be so nice if we could. Shouldn't be too hard to like simulate the visuals of this with the data we have without actually instantiating grass straws for it. I think we can manage. This, however. This looks so much better. We will see when I'm when I'm gonna focus on that. And that's just a little bit of a pivot where I don't want to spend more time on that one right now. It does look beautiful, the grass, but like this popping sucks. So what do we have when it comes to the terrain? Okay, we have a proper system for terrain neighbors. Both in terrain base and terrain patch. And then we calculate the normals using this one, and that works. Terrain data container, what do we do here? Get normals from height. Nah. Although, terrain patch, when we do this, like recalculate normals, we could probably calculate the normals. But do we want to do it here? Yeah, I don't see the difference between doing it here and here. Like, I wonder, we could probably change this one to it's delta. This we probably want to make this into what I'm trying to get at is it might be we're doing this in 2 for loops right now. So here we have a double for loop. Here we have a double for loop. We might just put this in here. So when we have calculated the vertex, we just calculate the normal as well. So just to mesh, normals is equal to normals. Dimension resolution private vector 2 delta. Do this, and oh, we actually create normals here, great. And then we can do so vector 3 Calculate normal from height, int I, int j. Remove this, remove that. Return normal normalized, and we can also do, we scale it here, so let's just do, what is it we scale with? Remove that and normalized here and return new vector. We don't call this one, we just assign the normals because we calculate the normal here, I think. Do I want to do... Like, is there a reason to save it like this, or just do... UV index is equal to... What's up, Fabric? And vertices are equal to... Okay, let's do it like this. Normals index is equal to normal, and then normal is, and do calculate normal from height I j, and that's all we need. Should be able to do it like this, I think. Okay, still works. Nice. What's up, Cooler SK? So how's the fight with terrain going? It's going pretty good, I would say. We've got the normals to be calculated correctly between the patches. And we have set up a system for communication between patches, but it's not the prettiest one. That's for sure. Something I would like to implement as well is like right now Okay, so here's my question. Like, how much of a performance boost will we get if we implement some type of LOD system when it comes to this terrain? So each terrain check the distance to the camera. And if it's like, depending on that distance, we regenerate the mesh with way lower resolution. Or I guess there's a trade-off, but within certain values that should result in a better performance. So we have a subdivision of, what is it, 2. We have a resolution of 80 and a subdivision of 2, so each terrain here has 80 divided by 4, so 20. So each terrain patch is 20 times 20 vertices. I wonder, like, we might want to keep that resolution for these ones because they are closest to the camera. But for, like, how much performance boost would we get by taking, what is it, 4, 5, 10, 12, the 12 other ones and making them 10 times 10 dynamically. Cooler SK, but I'm getting close to finishing my commission. Nice. And what if you implement, like, now it feels again like I'm just reinventing the wheel, but okay, here's some thoughts again. What if you do frustum culling on the CPU as well when it comes to these terrain patches? So for instance, we compare the 4 corners to the camera direction, and if we're entirely sure this one is outside, we just disable it. Is that idiotic? I want to do so many tests here. Maybe it's time. Garden 160. Let's go 1000. Where's that to? But if you have it this big, you definitely want more resolution, right? So 250, 250. Actually, do you want 1000? Ooh, okay. Yeah, maybe it's a good idea to move away from on validate right now with this terrain. And with extremely, so we have a very small height map. I think it's 64 times 64, so we do get these shading artifacts right now, but this looks pretty good. 1000 times 1000. I think that would be pretty cool and fun research to do. Wow, is it this unoptimized right now? Yeah. Actually, what do we have? We have 2 times 2, we should have 4 times 4, so 16. I think, yeah, these. Yeah, let's remove on validate after this. But what do we have? What the fuck? Like, this is looking good indeed. What is with this performance? This is... How can we already have this type of performance? The boy on the moon indeed. Oh, maybe. What's up, JD? What have you done with the grass? We're just trying some things out here. We have the grass here. Oh Jesus, it's thick though, so we might need to do 4, maybe like that. And very bad performance. One sec. Why are we getting this bad performance? Okay, let's do it like this. Object type, material, and I thought I fixed this. Okay, let's add the grass just to this one, right? And ignore the hat. There we go. Still... Nah, we're still gonna work a lot on the grass, but that hat indeed. I thought I had fixed that issue with the hat, by the way. There's a lot of issues right now we're working with, but the grass visuals are pretty much done. We just need to optimize it a bit, improve the distance when we have grass in the distance. But okay, so I'm a big fan of how we can improve this grass a lot. Did you model the grass? Now we're generating it on the GPU pretty much. We're using a geometry shader for it. This actually looks pretty good. I'm a little bit worried about, like, we have some things we need to take care of when it comes to the performance and the grass. I want to try one thing though. Let's do 3 here. Oh fuck, we're gonna get some errors, right? Yeah, we're now working with such a big terrains that I might want to skip doing onValidate stuff. But maybe we don't want to regenerate it every time we change something here. Let's see. Actually, before we continue, we're gonna do one here. Prio fix hat physics on long phys, or actually time dot. What is it? Is it fixed time? Let's fix that. Add a button that regenerates the mesh. That is probably a great idea. That, like, not probably, that is a great idea. Let's see here. I've not worked that much with custom. Let's see here, edit, implement simple terrain generation. This one is done. Add button for regenerating mesh in why can't I write? There we go. Mesh in terrain base and remove terrain base dot on validate. So we're gonna do that tomorrow, but I have some yeah, definitely need to remove it on validate, at least when we work with this big. Yeah, that's probably the first thing we're gonna do tomorrow. And then again, this might be I don't know if we're ever gonna work. Yeah, maybe we will work with this big of a garden. But I want to try some things tomorrow, so I'm gonna write down some thoughts. Let's see here. Yeah. Thoughts. Actually, let's thoughts is thoughts. Let's rewrite some of these into implementation notes. Normal calculation, terrain patch communication, and optimizations, I think. So I actually want to try this tomorrow. I don't know, it might be a dumb idea, or it might be such a good idea that it's actually standard when it comes to terrain. I have no idea. But I want to do terrain patch CPU, actually frustum culling on the CPU. Terrain patch LOD regeneration on the CPU. And then we're gonna do terrain patch tessellation on the GPU. This, however, doesn't Unity camera have frustum culling? Yeah, it does, but I wonder, like, what I'm thinking about is, like, if we look in this direction, Unity doesn't frustum cull this. Like, it still sends this information to the GPU, right? What I wonder is if we can just, if the camera is in this direction, we disable this patch. I wonder if that's dumb. Does it make any sense? Or does Unity already do that? I don't know. I know that stuff behind the camera isn't being rendered, but that is frustum culling done on the GPU, right? Or is it? I do want this one as well, but it's gonna be weird when we go. It's gonna be a little bit weird when we do. Or will it? No, maybe not. No, I don't think it will be. Oops. We're gonna experiment and find out tomorrow, hopefully. Terrain patch, tessellation on GPU. Terrain patch. Frustum culling on the GPU. If we do tessellation ourselves, we're gonna have to do frustum culling ourselves on the GPU. Frustum culling is done on the CPU. The point with it is to reduce draw calls. Ooh. Okay. So that's just my lack of knowledge. So doing this manually then would be no point at all. Yeah, we're still gonna write it here. We might research it tomorrow. Like, I want to read up on this so I can put some notes down as well. For some culling on the GPU, and we also want to do back face culling on the GPU. Like, these two only apply if we do this. If we do this, we also need to do this. I do think I want to do this. But okay, frustum culling on the CPU is done on Unity. Yeah, you still need to have proper bounding boxes on procedurally generated meshes or it won't work properly. This one, yeah. Okay. My question is, then I think Unity terrain patch, does Unity recalculate the bounding boxes when we do this? So many things I want to figure out here. Okay. The more you know. So you think you need to do mesh recalculate. Let's take a look. I'm just gonna update this one. Mesh Unity. Oh, okay, yeah, mesh has recalculate bounds, says Fabric. There we go. Okay, so if we're gonna start off tomorrow with doing some research here. Thank you for all the help, Harukanen and Fabric. But, so it should be, if we do this, when we set the mesh, if we do this, after we have set the mesh, then this should be handled by Unity, right? So when we're looking in this direction, the mesh, the terrain patches behind us should be disabled and not included. So if we look like this, so this one should be disabled when we look in this direction, right? But oh but. Oh yeah, and we also have these things to do for performance. Yeah, okay, I think tomorrow is going to be very interesting. I think tomorrow we're going to do these, except for that one then. And might explore this. So move away from mesh filter, I think. Still. Yeah, and the first thing we're gonna do tomorrow as well is we're gonna implement a generate mesh instead of doing it on validate, because yeah, it takes too much time and we end up with double generated stuff sometimes, so that's not good. But you know max height and the bounds already, right? So doing the recalc thing is pretty pricey, so if you already know that, you can set it. Oh, that's true. We can set the bounds ourselves instead. That's definitely true. But okay, we get simple terrain working with patched up with normal calculation going. Tomorrow we're gonna continue on this, lean a little bit more against optimization, because unfortunately I need to run now. But as always, thank you so much for watching, everybody, and thanks for the help as well. It's always appreciated. We'll be back tomorrow. Have a great rest of the day. Peace. Thank you, Benjamin, and have a great rest.